Hello everyone, my name is Anton. I made a big video about comparing different 3D cameras. But one popular camera was missing because I didn't have the access to it. It was Orbbec. And I actually asked them if they wanted to send me a camera for this video, and they kindly agreed. In this video, I will try to show you the main strange point of this camera, and its problem. Unfortunately, I will not be able to set up one-to-one setup like that was in my previous video about comparing a lot of cameras, but I will try to go through all cases that was for previous camera, and actually specifically for this camera I will do a little bit more, I will go through basic ideas about how to set up this camera, how to work with this camera, because previously it was too complex to do this in the video when I had like dozen of cameras. So in this video you will see general overview of this camera, how to set up and run this camera, a little bit more about accuracies, like comparing with on different environments, how it's working, estimation of accuracy and so on. And actually a small life hack, how to improve accuracy specifically for this, not this camera, but for all stereo cameras. So let's go. And let's talk about this camera first. When talking about the camera, I will use terminology about 3D cameras. And if you don't know how different cameras differ from each other, please take a look at my article like few years old about different approaches to reconstruct stereo depth image from cameras. And it will make your life a little bit easier. So I have an Orbbec Gemini 335L camera, and let's look at the most important characteristics. First of all, this is a stereo camera. It has two infrared cameras. They are right here, and it's the main source of the 3D camera. On the center there is installed the projector, that's projecting laser pattern, and it's significantly improve quality of 3D restoration especially for dark environment when there is not enough light and not enough texture. Also, it's improving reconstruction on environment where there is no information, for example, plain white paper or something like this. The distance between these cameras, infrared cameras, it's 9.5 centimeters, and it's called stereo base, and it's actually specifically for this camera it's pretty big. So here I have Orbbec D Pro camera for comparison, and as you can see, this one is a little bit bigger, and because of this camera can reconstruct distances on a longer distance. So also this camera has a global shutter, and it's pretty important characteristics because it's usually more top-tier cameras has these characteristics. What are the closest competitors? Of course, it's one of the closest. It's Orbbec D Pro V. It also has laser pattern and stereo camera, but the distance between optical centers is 7.5 centimeters, while the price is around the same. The main advantage of Orbbec D Pro, it's it has like internal coprocessor, like in the Myriad, but it's like a little bit like complex question. If you want to check about this camera, you can look at my previous video about specifically this camera. It's like it's cameras for a little bit different maybe cases, and specifically this one has a little bit better like base, which allows this camera work with a little bit bigger distances. But of course, if you need like to work close, maybe it's better to look on this camera or even on cameras when the stereo base is even smaller. The next competitor is D455 from RealSense from Intel. I don't have like specifically overview for this camera, but you can check like my previous video where there was a lot of different cameras. And I didn't find the official price for this camera, but the price should be around 400 USD dollars, which is a little bit more than this camera. This one is 360. For RealSense D455, the distance between the lenses is 9.5 centimeters, which is basically the same distance. It also has like active illumination with projector, and it also has like rolling global shutter. So it's basically super similar and super close camera in comparison with this one, the closest one. And the next close camera is Z2 or ZX camera. They a little bit different. They have even a larger base. Not a lot, but a little bit. But there is no active illumination, and the price is much bigger. It's from 450 to 600 USD dollars. In my previous videos, all these competitors was there, and for this video, I will check specifically this one. So, speaking from like, in my opinion, the main characteristics, it's like this, like the distance for stereo base, the shutter type, and how 3D is reconstructed. Like, is there any active laser illumination? So let's speak a little bit more about design and construction of these cameras. And in my opinion, it's pretty similar. Like, it's looking almost the same. Both like cameras, it's metal, connectivity is almost the same. Maybe the only difference, like, it's this camera has tripod in the same box with pretty good connection cable, which is a little bit better than different cameras. But in my opinion, like, for this price, it's definitely one of the cheapest camera, which give almost the same quality of the image and same quality of the depth. All these cameras that I mentioned, they are not dust and moisture proof. Expect the most expensive Z cameras, but like for this one you can buy a different version of this camera, much more expensive, and it will be waterproof. And I think there are some custom cases for RealSense cameras that can be waterproof. So let's talk about like software, how to run this camera, and how it's working. And for most use cases, you just can use the viewer application, which is basically like you can connect to this camera, check a little bit, like change all configuration, look how image will look like for each camera independently, and so on. But to access this camera, you need, of course, like to use like your Python or C++ code. And unfortunately, you need to build your project like from scratch for Python and for C++, of course. You just can't do pip install. It's like it's a little bit. It's look like a standard because there are a lot of cameras that are working like this. But in my opinion, like it's pretty easy to create the wheel for Python, and I hope they will fix this in future. Because like for OAK-D, it's a little bit easier to connect OAK-D for a new PC. But for RealSense, it's almost the same. So, let me go like through this process of connecting this camera to Linux system. Here I'm compiling and installing Orbbec SDK on a new board. Specifically here it's ARM board from Huawei, but in general it's working everywhere. I tested this with Rockchip board and with a few different boards. After compilation we are just installing this library, and I will perform a few tests with Python to show that everything is working now. I'm trying to run a few minimal functions to grab the image and normalize the output. Here was like all this connection pipeline, and let's look on different complex objects. And here you can see the first example with dark objects, like a few dark objects, and as you can see the quality is like pretty nice. Of course it's like not good enough to pick them with a robot, for example, but texture usually exists, and usually most part of the object is visible in 3D. And here there are a few examples with rounded edges, and as you can see they are pretty stable. Maybe like it's not super stable in the background, but of course it's because the lack of visibility there, like just one camera can look behind the object. So the results are also pretty similar, probably like OAK-D is a little bit worse and RealSense is super similar, but for OAK-D you can use different algorithms to reconstruct 3D, which we will discuss a little bit later. Here you can check how Orbbec camera looks through the window. And we already saw pretty similar effects for different cameras, like the window is not observable and it's kind of okay, but you can see there is a lot of noise behind the window. It's pretty common, so nothing new here. And for objects with glare, it's working, but of course, like the quality is dropping. And of course, it doesn't work for glass. So pretty classic result here as well. So, of course, like it's not ideal, but in general, it's basically the same, super close to images that it was like for RealSense and for this camera. The main interesting point that maybe like that camera was a little bit better in the mode where it's using like a lot of computational power. And here I want to talk a little bit about tricks. And the main trick that today, when you are creating like any robotic application or so on, you basically can take your own neural network that will give you like your depth map. And depending on your like computational unit, this network can be a little bit different. For example, for OOCD, it's basically you can put some networks like directly on the camera, but only the smallest one. And for Orbbec, it's impossible to put your network on the camera, but you can run your network on your PC. And for example, just a few images from this camera that are restored on different neural networks. And of course, these images, they are like much better than images from original depth images from this camera. And it's like the main trick. You just can take existing neural networks or train your own neural network that will restore much better than this camera is originally restored. And here we like have the main point. The main reason for all these cameras today is to provide the stable stereo camera in good case where it's not affected like by different temperature, by vibration and so on. And the main reason for such cameras is just have good case, good software around, good connectivity and so on. And actually this Orbbec camera is providing this, and but to have your depths, you just can take any of 3D like network and just use it. So please write your thoughts in your comments. If you want, I can like shot a video about all this 3D reconstruction. And hope I see you in the next video. Bye.